In terms of identifying rock units, they use various geophysical methods. We have aeromagnetics. Now, the plan on the left side, you can see clearly the four lobes of the Bushveld complex delineated. And the Pilanesberg alkaline complex is in the western lobe, sort of in the center. So that magnetic survey separates the different rock layers, and you can see the lineations, the structural features, faults, dikes, etc. And then gravity works basically on the mass of the rock. So you can see the four lobes of the Bushveld complex making prominent lobes due to the large mass of rock that is shown there. This is now on Rustenberg platinum mines. It's quite interesting here. You can see the different layers of the Bushveld complex. There's a cyanide dike which is colored orange there. Now this cyanide dike infilled a radial fracture which runs from the Pilanesberg complex, goes through Rustenberg all the way to Krugersdorp. It's about 40 meters thick. So it's a red cyanide. The dolerite dikes are more magnetic, so they show up more clearly as a dark blue feature. There's a zone where a dunite pipe intruded the Bushveld later on, and there was extensive potholing and disruption of the Bushveld layers, which is shown in that 1.5 kilometer wide disturbed zone. This is a map of the Bushveld complex showing the different lobes and the rock layers. We have the blue and orange is a Transvaal group, and then we have the Bushveld intrusion on the green and the main critical and lower zones. You can see the Pilanesberg is a sort of a grey circle which came through and was intruded through the Transvaal sediments and the Bushveld, a younger event. And then we have the granites, the Rustenberg granophyre and Loboa granite in the center of the complex towards the top, in which the tin occurs. This is the age of the various cycles. So we've got the Witwatersrand group in which the gold deposits were formed. Then we have the Ventersdorp lavas and sandstones. And then subsequent to that we had sedimentation 2,300 million years ago, in which this is where the Magaliesberg quartzites were laid down, which we'll discuss briefly. And then the Bushveld complex was intruded. So it's a huge magma chamber that was intruded subsurface in 2050 million years and then differentiated. Then we had the Waterberg group, and then 1,300 million years ago, the Pilanesberg alkali volcano erupted. This is a picture of the Magaliesberg quartzites near Rustenberg. Now, there's a huge Rustenberg fault that cuts through here, through Olifant's Neck and through the Kashan Nature Reserve. At the top, the Rustenberg Nature Reserve. And this fault has a massive lateral shift on it. They talk of more than 1 kilometer, and it apparently has a downthrow to the northeast side. Magaliesberg quartzite is about 98 to 99% silicon dioxide, It's almost pure silicon, and they mine it at Bronkhorstspruit, and then also here near Hardebeespoort Dam. And it's quite commonly used to make glass if it's pure enough. Then we have Tabazibi iron ore mine, which is mainly hematite. We have banded iron formations also at Tabazimbi. So that's in the Transvaal. This is again a satellite imagery of this western lobe of the Bushveld complex. So we see the Pilanesberg circular feature in the middle. We have the Rustenberg compartment of the igneous complex, and then we have Union and the Mandelbrot separated by the gap. So you can see the different rock layers and the different colors and features. Okay, so now we come to the Pilanesberg. Professor Grant Cawthorne of Wits University compiled a very nice little information circular that used to be available at the Pilanesberg, but I don't think you can get it anymore. So this alkaline volcano erupted, as I said, 1,300 million years ago. That's to give you an idea of what it looks like. You'll see that the magma in the Pluton came up, and it made use of radial or circular fractures and came up the side of the volcano. So the oldest units are in the middle of the volcano, and then as you go towards the outside, they get younger. The ring-like structure, what's happened now is the whole top of the volcano has been eroded or basically planed off, and the more resistant units are forming circular rings, and the softer material is eroded, forming valleys. This is from Google Earth. Here you can see very nicely the ring structure, the circular nature of these various rock layers. Here is a geological map, also compiled by Grant Cawthorne. Now, these are the different rock types that you get there. So we've got volcanics that came out: red foyite, green foyite, red syenite, leadifoyite, white foyite, tinguite, which is actually a phonolite, and there's two kimberlite, diamond kimberlite pipes in the Pilanesberg. Now, in the old days, there used to be like a geological tour you could drive, and they had polished rocks that you could stop and had a look at. But lately they've got lions there, so it's not a good idea to get out of your car and go and have a look. The other thing that was mined was the fluorite mine, which is near Kubu Drive. I think it's called Mupa Fluorite Mine. So we actually went to visit it. We had an armed guard with a rifle to keep the rhinos at bay, and I collected some samples there which have been polished. So a lot of these samples were collected like many years ago, before everything became so formed. So this is from the fluorite mine. This is what they call a dendritic mineral or formation. It looks like a fern, okay, or a fir tree. So this is a more detailed geological map now of this area, showing you the different rocks and their ages. So we have the Crocodile River fragment there at Brits, which is a big down-thrown block, Pilanesberg alkaline complex, and then the various zones, and then the reef, major platinum bearing reefs are in the critical zone, the Marensky Reef and the UG2 Reef. To the north of the Pilansberg, we have the Union section, and then there's what they call a gap where there's no bushveld rocks. And then we have a Mandelbrot section. They're all dipping inwards to the center of the complex at about 20 degrees odd. So I did a lot of exploration on the bushveld, both for chrome and platinum, various deposits. I had one on the northern side of Pilansberg at Kreitfontein, and then on Rustenberg platinum mines, and in Mooinooi and Kroondal. So we had a big seismic study on Rustenberg platinum mines, where they use these huge vibrator machines. They put this pad down on the ground and they shake it, and then the vibrations bounce off the rock types and they can pick up the layering. So this is now what the end product looks like. So on this study, they discovered, or they delineated, this huge pothole feature or depression in the rock layers. And there was a major downthrow fault that no one knew about. So that 40-meter cyanide dike is the one that comes from Pilansberg and cuts through Rustenberg. Basically, the bushveld complex was a huge chamber of molten magma, but there was inside there was convective flow of the different magma units, and different flow patterns developed, which resulted in erosion and deposition of various layers inside the complex. This is now a very simple schematic section of the different layers in the bushveld complex. We have the lower group chromatites, which are mined. LG6 is probably the major chrome, high-quality chrome producer. And then in the middle group, the MG1 and the MG2 are the major chrome producers. Recently, at Theresa mines, they've been mining MG3 and MG4, but also extracting the platinum group metals. Then higher up, we have the upper group chromatite seams. The UG2 is a major platinum producing chrome seam. And then, of course, the famous Merensky reef is the major platinum-rich reef. And the various rock types are indicated there on the color scheme. So this is the LG6 chromite seam. I worked at Millcell for 5 years, so we were mining this. It's a higher quality chrome that everyone wants around the world. This is an open cast exposure of the chrome seams at Thorncliffe, but we have similar ones around here where they've mined. Here we see the MG1 is on the far left, just behind the truck's bucket, and then the MG2 is below the white layer in the middle. That's your MG2 A, B, and C reefs. And then the MG3 is above the white layer, and then right at the top on the right-hand side is the MG4 chrome seam. So this is again another open cast showing the MG1 in the bottom by the water, MG2 below the white layer, and, which is modeled anorthosite, and then the MG3 on top of that. This is what the MG1 chrome seam is, also high quality chrome, looks like. It has some stringers at the bottom. It's about 1.3 meters thick and has a thin parting in the middle. This is the MG2, which is mined extensively at Mooinooi, Western Chrome Mines. And those are the 3 chrome seams with the pyroxenite layers or waste partings in the middle. This is again an outcrop of the MG2 and MG3 chromatite seams. Then above that we have the MG4 This was now mined at Theresa, but more for the platinum content. The chrome quality is not good. So these are the products. This is what we produce and we sell overseas. The Chinese buy most of our chrome and make it into ferrochrome. We have a number of ferrochrome plants in South Africa, Middelburg and all over. There's a number of them, and I think Samancor is the major chrome producer in the world. Now we go to the upper group, chromatite seams. This is the UG1, which is not really economic, but it's quite spectacular. The northern was still a bit soft. It was a little bit molten when the chrome was intruded, and hence it got deformed and formed various. It's got quite fascinating features that you can see. So we have these various layers of anorthosite and chromite in the UG1. Now this is one of our major platinum producing reefs, the UG2 main seam chromatite. It's about 80 centimeters thick, 6 grams per ton of PGEs. It's enriched in rhodium, which has a good price, that makes it very interesting, whereas Merensky reef is more enriched in platinum. This is another picture of the main seam at Bleskop, where it's sitting on the Bleskop marker. This picture comes from the Marikana platinum mine. Here we have a depression or a pothole in the reef, which was the layering is disturbed, and the UG2 cuts down into the footwall rocks. So now we come to the Merensky reef. Merensky reef has a slightly anorthositic layer immediately below it. Then it has a basal chrome seam shown in red there, and then a pegmatoidal feldspathic peroxenite overlain by a top chrome seam. So between those two red lines is where the most PGEs occur, and then upwards in the immediate hanging wall and footwall. So the footwall is a norite, and the hanging wall is a peroxenite, and it's running about 8 grams per ton, and mainly PGE enriched. Here's another picture. This one you can see the two chrome seams quite clearly, and then your pegmatoidal feldspathic peroxenite, which contains most of the base metal sulfides and PGEs. So this is now a split of the various platinum group elements. So what is in the reef? What's the split? This is just a general to give you an idea. So when I say Merensky reef is platinum enriched, 60% of the PGEs are there. UG2 reef, it's 49%. Then we move on finally to the main magnetite layer. So we have in the upper group, we have titaniferous magnetite, which is vanadium, carries 2 to 3% of vanadium in there. So this is right near Mokopane sub-outcrop. You can see the outcrop running basically into the picture that's on surface. And this is going to be mined quite extensively in the future for vanadium. So in terms of iron ore, we have, I don't know if Francois can tell us where they get their iron ore from that they smelt in the, but we have banded ironstone formations, we have the hematite at Tabazimbi, and we have magnetites here in Mokopane and further up in northwest. So there's another picture of the outcrop of the main magnetite layer. What are the products of vanadium that one gets? There's a whole host of products that they derived. This comes from Bushveld Minerals website, and it just gives you all the different products that they produce from their operations. So there's quite a lot. The processing of this titaniferous magnetite is pretty complicated. It's not an easy process at all. Yeah, so that's about it. I don't know if there's any questions.